Good morning everyone. Today we are going to study about the deviation of actual vapor cycle from that of the ideal one. Till now we have studied regarding the ideal vapor power cycle. So what does an ideal vapor power cycle looks like and how it deviates from an ideal Rankine cycle? The main reason for deviation of an ideal vapor power cycle is first one, fluid friction. Because of frictional losses there is a deviation, then irreversibilities in the pump and the turbine. So you can see here an actual isentropic expansion looks like this 3 to 4 is an isentropic expansion. But actually what happens is 3 to 4 dash. Isentropic compression is 1 to 2. But in an actual one it is 1 to 2 dash. So calculating the turbine efficiency is equal to H3 minus H4 dash divided by H3 minus H4. So H3 minus H4 is what? An ideal expansion process. So the amount of work done in H3 minus H4 will be always greater, while that of H3 minus H4 dash will be always less because of the friction losses. So we can say this somewhat like this is an input, this is an output. So actual ideally it should have been H3 minus H4, but it's not so. It is H3 minus H4 dash. So H3 minus H4 dash by H3 minus H4, that is the turbine efficiency. For pump, we know that the amount of work done should be less. The amount, because it is a power consuming device, H1 minus, that is H2 minus H1 is always less because of its power consuming. It is a power consuming component. So H2 minus H1 it is always should be less, while H2 minus H2 dash minus H1 should be, or it will be always more. But our aim is to reduce the pump work, while our aim is to increase the turbine work, because of the pumping power should be always less here. But because of an because it is not an isentropic process and it deviates H1 minus H2 dash, the ideal one will have more, it will consume lot of power. That's why the pumping efficiency is H2 minus H1, that is the greater element, while it is the lesser value, while H2 dash minus H1 is the higher value. Next topic is how to increase the efficiency of the Rankine cycle. So there are three methods. First is lowering the condenser pressure. So if you lower the condenser pressure, what we can do is lower the condenser pressure. See here, the actual condenser pressure is 1 to 4. This is the actual condenser pressure. We have lowered the condenser pressure to 1 to 4 dash, that is 4 dash. 4 to 4 dash we have decreased the lower condenser. We have decreased the condenser. If increase the area of this box, what will happen? The efficiency will automatically increase. But what is the one main disadvantage of lowering the condenser pressure is, we see that when we lower the value of 4 to 4 dash, we see wetness of the steam also increases. We already know that whatever comes under this dome is what? It is a wet plus it is a vapor plus liquid. So if we go lower and lower, what will happen is, if we are increasing the water content in our stream, that is dryness fraction gets lesser, that is quality of stream decreases. So one main disadvantage is that we can lower the condenser pressure, but along with lowering of the condenser pressure, the moisture content in the steam decreases. Moisture content in the steam increases. If moisture is more, it is harmful for our turbine blades. Next step in increasing the Rankine cycle efficiency is superheating the steam to high temperature. If we can superheat the steam to very high temperature, what will happen? The value will increase from 3 to 3 dash. So what we are doing, it is very advantageous. Mainly we are increasing the heating temperature to 3 to 3 dash. We are increasing the overall box area, that is we are increasing the efficiency. So 3 to 3 dash. So moisture content is also less, it is the quality of the steam is also more, and also efficiency is also increasing. It has both advantages, but the main disadvantage is that we cannot go beyond certain temperature because of our material limitations. We cannot, because our materials cannot withstand certain high temperature. We can't go beyond certain temperature, that is 620 degree. 620 degree is the limit. Next step is we can increase the boiler pressure. So what is increasing the boiler pressure? So normally this is the boiler pressure. If increase the boiler pressure, it's 3. This is the boiler pressure value. If increase the boiler pressure, our curve goes like this. It is increasing. So here we can see here there is increase in work done, but here you can see there is no increase in work done. So there is an increase here but decrease here. But main disadvantages of this increasing the boiler pressure is three. You can see actually our expansion was from 3 to 4, but as you increase the boiler pressure it will be from 3 dash to 4 dash. If we increase the boiler pressure, what will happen is the quality of the steam decreases. If the quality of the steam decreases, it is always disadvantageous because the moisture content will increase. If the moisture content will increase, what will happen, guys? So it is harmful to our blades of the turbine. So what we can do? So how to increase the efficiency? So mainly what we can do is we can go as high as we can increase the temperatures as high as our materials can withstand. Then we can do one thing, that is reheat. So it is one of the most important point, that is reheating. So in a reheating, what happens is we normally superheat the steam, or at a normally there will be two types of turbine. One is high pressure turbine, another is low pressure turbine. So in a high pressure turbine, the steam enters the high pressure turbine at a higher pressure, at a 3. So after it gets expanded and from 3 to 4, again it is reheated to a temperature of 5. Again it is reheated to the same temperature, you can see here, to 0.5. Then it is expanded in a low pressure turbine till the point number 6. So by using a reheat, we are mainly avoiding one major disadvantage, that is the moisture content. If we can see here, if you remember there, if we increase the boiler pressure, what will happen? The moisture content will be more moisture content. So what we are doing to avoid this major issue, instead of increasing, not only increasing the boiler pressure, along with increasing the boiler pressure, we are also reheating the steam after expansion. So we are producing work in two stages, that is single reheat turbine. So sorry, it is we are reheating twice. So you can see here what is happening here. First of all, from the boiler, the steam will go from the boiler into the high pressure turbine. Then it expands from 3 to 4, 3 to 4. Then gets reheated again. Then after getting reheated, it is passed through a low pressure turbine. Then it is then passed through a condenser. Then after condensation, it is pumped into again to the boiler. That is 3 to 4 is high pressure, reheated. 5 to 6 is low pressure turbine. Then again it is condensed, pumped back to the boiler. Then same thing repeats. So we will conclude today's lecture, today's session. Thank you.